and good morning or afternoon, depending on your location. And I'll begin with a few webinar announcements and also follow that up with a brief 4-slide introduction. So, on behalf of Convergent Science, thank you for joining us today, and thank you for your attention in advance. My name is Tiffany, and I will be your host for the hour. I'd also like to thank Rescale for their participation. We have a long-standing partnership, and their resources have truly added value to the Converge experience for our clients. So we're happy for them to be able to share or refresh the audience on the specifics of how to use the platform today. So for those that are not familiar with Convergent Science, we were established by graduate students at University of Wisconsin in Madison. And in the picture, there are 3 of the 4 owners at our home base or headquarters, which is also in Madison, Wisconsin. And as of today, we have offices in Texas, which is where I'm located, in addition to the 4th owner, Michigan, Austria, and India, in addition to distribution in Asia through a collaboration with IDAJ. So at Convergent Science, our flagship product is Converge CFD software, and our key feature is Adaptive Mesh Refinement, or AMR. We do pride ourselves on this feature, and basically what it does is eliminate the grid generation bottleneck from the CFD simulation process. And if you're familiar with our code, you know we've done quite well in the IC engine area, but Converge can also be applied to the application areas that you see here. And so along with the benefits indicated, Converge also has various options for that are specific to your needs. So we have options for grid generation, chemistry, spray models, combustion models, emissions, and turbulence. So I just want to take this time to invite you to visit our website, to check out our resources, and get more detailed information on our applications, features, and benefits. I'd also like to add that this year marks the 10th year that Converge has been commercially available. At this point, approximately 95% of the U.S. engine makers use Converge, and 85% of engine makers in Europe and Japan use Converge. But as you saw on our previous slide, we do go beyond engines. We continue to improve our capabilities, and Converge 3.0 is coming soon. Just stay tuned. And finally, we have a few upcoming trainings in our Wisconsin and Michigan offices. Registration can be found on our website, which the link is there. So at that point, my portion is done. I will now turn it over to Bernardo from Rescale, and then over to my colleague, Sean.
All right. Thank you, Tiffany, for that introduction. And I want to get started by talking about who Rescale is, what we do. So Rescale is a platform that delivers the total HPC experience for engineers with a simple and easy to use web interface. So really our users are focused on running their software applications like Converge on the latest, most reliable and flexible set of compute technologies available. Rescale connects them to a vast set of hardware providers on their world-class security layers to protect corporate IP. Rescale also offers a fully integrated stack of enterprise deployment tools. And what do we mean with that? So when you buy an on-premise stack, right, you must address each of the layers shown here on the left. You acquire the applications, the licensing, support, schedulers, networking, infrastructure, all of it. So each of these choices represents a capital expense and a huge opportunity cost. Not to mention that integrating these tools requires consulting services and significant effort. So Rescale encapsulates this entire stack, make it just a streamline as a turnkey solution in a pay-per-use model. Now, I want to talk about what are the fundamental values at Rescale, right, that we pride from our solution. So first of all, Rescale, it's a platform. And there are 3 ways you can leverage Rescale in your HPC program. You can use it as a cloud native application where you submit your jobs through the platform to cloud. You can connect it to your on-premise HPC. Well, you will be submitting your jobs through the platform and sending them to your on-premise scheduler, but still retaining the administration portal, analysis, and reporting capabilities that Rescale offers. And lastly, the on-hybrid solution, where the advantages of both implementations are leveraged, allowing users to extend to the cloud and on demand and basically transition between them based on their workloads. Now, there's no right solution, right answer here. I mean, you can pretty much customize and build your solution according to your needs. Now, the first value is that we offer an optimized solution. So, on this topic, I mean, we know that not all simulations are created equal, and as such, you want to make sure you run in the optimal hardware for each particular case. So imagine that every time you launch an HPC task for a Converge model that you want to run, you can choose what is the hardware that you're going to run, what is the core type that you want to run, the architecture for that core type, whether you're leveraging your simulation with a GPU or not. And by the time that you submit this job, Rescale will create this entire stack and run it with a configuration that you choose. If you later on need to do a different configuration for a different model, we have already optimized all those different configurations that are available to you for your simulation. Now, Rescale is scalable as well. So for this, I mean, the best way to talk about it is showing this picture, right? No one likes to wait in a queue. Like in this scene of the bank, right? I mean, you can see that everyone is just thinking to themselves, why don't they have more tellers? I mean, don't they understand the demand? And in an engineering scenario, it's the same when your job has to wait in queue. Now, in that case, it's not only frustrating, but it's also extremely expensive for the organization. What would be better? Well, it would be better if the resources become available as soon as the demand arrives, right? Like with the airport kiosk, um, pretty much, I mean, they solve this problem by having just that offer that pretty much comes on demand, right? So this is a fundamental concept that Rescale offers with its ability to scale out simulations, deploying in your organization with all the administration and controls that you would need. And on this topic, right, I mean, there's also this particular example that I always like to show. And this is from an exercise that we did with one of our tier one suppliers. So basically, you can see that we're plotting here the HPC demand against time. So the question now comes up, right, is, well, if they're buying an on-prem system, how big should it be? Sure, I mean, they can invest, $20 million to buy a system that we cover all the demand, but then it would only be 20% utilized. Now, if they go for a $4 million system, well, you can see that, yes, I mean, utilization will be high, but there will points of time where they will just have periods of unmet demand and jobs will be queued. Now, Rescale breaks this paradigm and offers the users to access to run their jobs when they need it and to only pay when they're running jobs. And of course, that it's a turnkey solution, right? And I think, I mean, we mentioned this before. Having access to all of this functionality and also via a web-based portal leaves you access without having to install any additional tools to allow you to run your simulations with us. So in summary, Rescale delivers an HPC platform that is optimized, scalable, and a turnkey solution. Now, we also have a worldwide infrastructure through our partners, providing over 100 data centers around the world, and we keep security as one of our core values, right? I mean, we run under the highest standards of security as we're certified by SOC Type 2, CSA registered, ITAR compliant, and HIPAA certified as well. So with that, I just wanted to provide a short introduction, and now I'm gonna pass it on to Tiffany to talk about the model that we ran on Rescale.
Okay, and actually, I will pass control over to Sean so that he can talk about the model.
Thank you, Bernardo. Let me take a moment to walk through the Converge model that was used to do the Rescale benchmark. The model can be obtained by going through Converge Studio in our examples library case. You can navigate to the internal combustion engines and go to the Spark Ignition PFI library set and go down to the SI8 engine PFI SAGE example case. Let me take a moment to quickly walk through the geometry, and then I will describe the physical models that were used. So this is the model. It is a 4-stroke port fuel injected gasoline engine model. It includes geometry of this pink region is an intake runner, the intake ports, the cylinder, combustion chamber, and the exhaust ports. And if I disable viewing of the piston and liner, we also have the moving intake valves, exhaust valves, and a geometry for the centrally located spark plug. In addition, what we also have here is a fuel injector located in the intake port that has 4 separate nozzle holes spraying 2 sprays on the back of each intake valve. All right, that kind of summarizes the geometry that was used. Let me briefly then go through the model setup. The model has a bore of 86 millimeters, a stroke of 90 millimeters, and a compression ratio of approximately 10 to 1, and the engine RPM was at 3,000 RPM. The next item here is the simulation run parameters. In this example, it shows we start the simulation at minus 520 crank degrees, and we actually, in the benchmark, extended the runtime from 120 to 840 crank degrees. So more than a single engine cycle. The next item here that I'd like to discuss is the physical models that were enabled. The first is the spray modeling. In this model, we are injecting pure isooctane with droplet evaporation. And specifically, the specific models that were enabled for the spray include the Kelvin-Helmholtz, KH, and Rayleigh-Taylor droplet breakup modeling schemes. We also include here the startup injection was at minus 400 crank degrees. The injection duration is 191 crank degrees, and the total mass injected is 30 milligrams of fuel. We inject 50,000 parcels per nozzle hole. We have 4 nozzles, so the total number of parcels being injected is 200,000 parcels. The next model that I'd like to describe is the combustion model. Because the model is called our SI8 engine PFI for port fuel injected and SAGE, so we have the SAGE detailed chemistry solver enabled. This model uses in this particular case, a reaction mechanism. That is, if we look at that, is the JA 2012 mechanism for the combustion of isooctane as our surrogate fuel. The other options set up for SAGE chemistry include a option for resolving temperature of 2 Kelvin, and these default values for the relative tolerance, absolute tolerance, and a reaction rate multiplier of 1, which is our default value. Next, I'll go into the turbulence model options, and here we have the standard engine turbulence model selected that we recommend is our Reynolds average Navier-Stokes RNG K epsilon turbulence model, and we have the default constants enabled for that turbulence model. Next, we have the source and sinks. We have these enabled for simulating the spark energy. One is an event that lasts from -15 to -14.5 crank degrees, which is the glow arc. And then we have another one which lasts from -15 to 5 crank degrees, which is the breakdown. Next, we go into some of the grid settings. Our base grid is 4 millimeters in each direction, X, Y, Z. And we have Adaptive Mesh Refinement enabled. It is active in the cylinder and in the intake port and intake runners. We have Velocity AMR enabled with a maximum embedding level of 3. So the minimum cell size will be 0.5 millimeter to resolve the velocity field. We also have temperature AMR active, and that is also at a maximum embed level of 3 and will resolve temperature down to 0.5 millimeter. Next, we look at some fixed embeddings that have been enabled. We have a fixed embedding inside the cylinder, or a cylindrical region, which encompasses the cylinder and a small region of the intake and exhaust ports. And we have then that is embedding down to 2 levels of down to 1 millimeter grid refinement. We have another embedding around the intake valve angles, which is active here, and also on the exhaust valve angles, active here, to resolve the small gap between the valves and the valve seats. Those are both, the intake valve angle is embedded down to a level of 3, so that'll be down to 0.5 millimeter, and the exhaust valve angle is embedded down only to a level of 2 to 1 millimeter. Next, we have some spherical embedding located at the spark plug gap. Let me show you where that is located. So we have spark embedding in a spherical region in the spark plug gap down to an embed level of 4. That would be down to 0.25 millimeters, and that becomes active just prior to the energy source being deposited in the spark gap. Okay, so next we have embedding of another embedding that goes down to a level of 5 also in the spark gap. And finally, we have injector embedding, which is embedding a region downstream of where the injector is located, and that is to refine down to an embed level of 4, where the spray will be injected in the intake port. That is also active just prior to the start of injection event and ends just after the end of injection. So with that basically summarizes the model that was used for the benchmark, and I thank you for your time.
All right, thank you, Sean and Tiffany. So now I'm going to talk about the results, right? I mean, so we took this model that Converge shared with us, and we ran two cases, right? Basically, one with a base mesh and one with a coarse mesh. Now, they were both run with 36 cores, and basically, we chose two different core types, one with Haswell and one with SkyLake Intel architectures. And why did we pick this? Well, it's important to mention that the difference between these two architectures is 2 years, right? I mean, one was SkyLake was developed and released 2 years after Haswell. And this, for this case, it's important to show the benefit of having access to the latest technology, hardware technology available for your simulation, right? So you can see, for instance, on the left for the coarse mesh, how between Haswell and SkyLake, there's already a 20% improvement in time, and more importantly, 32% reduction in cost. This is already, this is linking not only the savings in time, but also it's including the cost of the hardware as well. And now for the base mesh as well, you can see that perhaps the saving in time is just like around 7%, but then keep in mind that this took a lot longer to run. And also, I can't stress enough the importance of the cost saving. 20% for anyone that would represent a huge saving. So how long would it take you to update an on-prem system or your hardware, right? If you're running on a Haswell architecture, if 2 years after you requested, there's now a new core type available, right? Typically, I mean, you have to wait, anywhere from 3 to 5 to 6 years, and then maybe some more until a new technology would be made available to your on-prem system. With Rescale, the moment it's available, you can immediately transfer all your workload to the latest hardware architecture. So with that being said, I'm now going to show you how you can actually run your Converge models on Rescale on a quick demo. First of all, I would invite everyone to go to our website, rescale.com, and you can sign up for an account. I mean, it's very easy. It doesn't take you more than 5 minutes, and you'll have access to pretty much everything that I'm going to show you today. Once you create an account, you'll start here, right? I mean, this will be the dashboard that you'll be facing, and this is the ScaleX platform. So you can see that it's very intuitive. So right on the top left corner, you can start creating a new job. And now under here, you can start by giving your simulation a name. So I'm gonna call it Converge Test 1.0. Now here on the front of your screen, you'll get the workflow for setting up a basic job. It goes from left to right, and pretty much it's very intuitive as well, right? I mean, you have to define your inputs, your software, your hardware, and post-processing as an optional step. So we'll go into each one of these. So first, for the inputs. Now, you have the option to upload the files directly from your computer, or if you have already uploaded them before to your Rescale account, or if you have another type of cloud storage, you can access them from there. In this case, I already have my file uploaded on Rescale. Now, you can also notice that this is a zip file. So, of course, I mean, this will help me upload my files faster, but also, right, Rescale will decompress it before the simulation is run. So it just makes things more efficient. Now, inside this zip file, all that I have is my input files, my data files for my Converge simulation. So for the next step, now I get to look for my Converge application. And now here, you're also presented with multiple versions for Converge. We typically maintain the last 3 years of releases, But then again, if there's one particular build that you want to run that is not listed here, you can reach out to us, and basically, I mean, for that request, it takes anywhere from 1 to 2 weeks to make it available, so we can add it pretty easily. Then for the command, this is a bash window. So the execution command, I mean, it's very simple. I mean, it's already configured in the background, so there's nothing that you need to do. But being a bash window, you can also add, other commands. If there's any, pre-processing or file managing that you want to do as well, you can just write the lines straight on this window. And finally, for the license options with Converge, you can actually get Converge licenses on demand through Rescale. The only requirement is that you're already a Converge customer, and upon approval from Convergent, you'll be able to also acquire on-demand licenses with us. The other alternative is to use your existing license. And for that, we can connect to your on-prem license server, establishing either an SSH tunnel or a VPN tunnel to connect to your server. So in this case, I'm gonna go for the on-demand mode. And now we get to pick our hardware. So this is where Rescale truly shines, right? I mean, you have access to a vast set of different core types, and you can see, starting from the left, that you can look at what type of architecture does it have, as well as I mentioned, as one of the cases that we ran, SkyLake as another one. You can look at the clock speed of the core type. Then you can look at the memory, the RAM memory, I mean, for each core type, the interconnect speed, and the storage, the solid state drive associated to each core. So in this case, I'm just gonna pick the Onyx core type. And now here in the bottom is where you get to choose the number of cores. And you can go, pretty much as high as you want, provided that your model offers you good scaling. This is one of the benefits of having access to pretty much unlimited resources on the cloud. So for this simulation, I'm going to scale it down a little bit. I'm going to run just with 18 cores. And of course, you can also set up a timeout if you're not sure. I mean, if your model will converge and you just want to add, an additional security feature, you can say, okay, only run for 24 hours, and it will immediately automatically shut down after that time. So post-processing, you can upload here again a Python script, a shell script, if you want to do some post-processing directly after your job is complete. In this case, I mean, I'm not gonna include a script for post-processing, and pretty much that's it, right? So with just a few clicks, we were able to define our inputs, software, and hardware, and now we're ready to run. So all we need to do now is just hit submit. Now there will be 4 stages as our job is running. First, we validate the inputs. We make sure, that we check, your software and hardware selection. We make sure that you have enough credits for your account. Then we would actually start the cluster. This is a phase where we provision the cluster, install the software, and then we run the job. Now you will only be billed for the 3rd step, when you're actually running the job. And of course, the final step, when we stop the cluster, we save all your results back into your Rescale account, and we shut down the cluster, and no more files are kept outside of what is stored in your account. So the process to validate and start a cluster typically goes anywhere from, I'll say, 3 to 6 minutes. So ahead of time, I already had a job running just to show you some of the things that you can monitor as your job is executing. So here you can see that first of all, you have some Converge stats. So right out of the Converge log file, we have built an interface that presents you with just some details about the model so that you can easily monitor how it's progressing. In addition, we have a window where you can do live tailing of any of the output files. So for instance, we can look at the process output log and check the progress of a run, or as I mentioned before, the Converge log file, right? And now you can see, look at the iterations that it's currently running and the residuals. So another important feature is, right, when people ask us, well, I have, very large files, and I just want to adjust either, one setting before I run it. Do I have to upload it again? Or, I want to make sure that the outputs look well before I download them. Well, for that case, then we also have desktops, and I'll take a step back to show you how to set them up. So basically, you can actually launch a desktop directly on Rescale. You can choose your Windows configuration, the tool, and the version of Converge that you'll be running, and then you can attach jobs, for the different analysis that you want to tie to your desktop. After you do that, there are two ways you can connect to your desktop, either directly through your browser or with a remote desktop client. Now, most of our users prefer the in-browser, so you just click on it and pretty much you're in there, right? I mean, you're inside a Windows terminal that will have a Converge Studio installed on it. From there, you can pretty much now have access to all your outputs. You can just check different plots, make sure that things look as you want it before you start downloading your files. So with that, the only additional note that I want to talk about is we also have best documentation. So you'll have access to our resources. You can go in here to see how to launch a basic job as the one I described. We have other workflows, such as the one for DOE. And of course, we have a lot of Converge examples available to you as well that you can download to your Rescale account and run them and try those models. In addition, if you need any help, you can contact us. So directly from here, you can send an email, and this email will go to support@rescale.com. Or you can just directly just send it to us, and someone will get back to you and help you out. I mean, for whatever Rescale needs you may have. And with that, I'm going to turn it back to Tiffany and see if anyone has any questions.
Thank you for that, Bernardo. We actually do have a few questions. Let's see. So the first question, if Rescale runs on cloud environments such as AWS, Azure, IBM, Google, or etc., why not go directly to the cloud provider?
Right. So that is a great question, and that is tied back to Rescale being able to provide the full stack of deployment tools, right? So yes, people, I mean, can go directly, I mean, to the cloud providers, but then they would have to install their application, configure it, tune it for the simulation that they want to run, and then they will have to do that every time they want to access the cloud provider, right? Otherwise, I mean, they will have it up and running and pay for the time that is up and running. Rescale will take that effort away from you, and then you'll have access to not only that individual cloud provider, but from multiple cloud providers without having to do anything but just focus on what is more important to you, which is getting your engineering simulation done.
Okay, great. We've got two more. Can I buy Converge licenses directly from Rescale?
Yes, absolutely. You can, provided two things that I mentioned before. You have to be already a Convergent Science customer, and we just need to get approval from them. But yes, that is also something that is available, so you can really benefit, from scaling on Rescale by having access to licenses on demand.
Okay, and the final question is, who does Rescale compete with?
Well, in that space, we're really competing against on-premises infrastructure, right? On-premise workload. We're seeing, this shift right now and we know, right? The demand for being able to run more projects, do more simulation, and crunching the timelines that you have to deliver your work, right? So your stress into delivering more, being able to run more simulations. So it's only natural to shift the workloads from your on-prem system to the cloud, right? Where you're able to do a lot more and using it when you need it.
Okay, and that's all the questions that we have. And again, I definitely invite you guys to visit the Rescale website or the Converge CFD website if you have any questions or just want to dig around and get a little bit more information. So thank you for your time, and I think we'll conclude with that.
Thank you, everyone.